Hello my dear G8 students. Welcome to my next video lesson. I'm going to split this lesson into two parts. First part will be continuation of our actual topic, so I'll be talking about buoyancy. And part 2 will be about your quick test you wrote last time about forces. I'm going to solve all exercises to you. Then, of course, still you have an access to your test. You can compare your solutions with mine solutions. Unfortunately, I found one mistake in one exercise, exercise number 5. I'll erase this exercise, but it will be later. Okay? So you can write a topic. The last topic was buoyant force and Archimedes law. So now you can write a topic as buoyancy. Okay, so as a revision of our last lesson, we were talking about a buoyant force. You know that when object is immersed in fluid, I've used as example of a liquid, that the object experiences another force called buoyant force. This buoyant force is always directed vertically upwards, okay, and is related with density of fluid in which object is immersed, okay, gravitational acceleration and volume of the immersed part of the object. When object is immersed at all, then of course we have to take volume of the object. If not at all, we have to take only the part which is below the surface of water. Of course, except the buoyancy, object also experiences gravitational force, which can be calculated by product of mass of the object and gravitational acceleration. Okay, and what is an Archimedes law? Archimedes law is related with existence of this buoyant force and says that when object is immersed in fluid, then part of the fluid is displaced, and the volume of this displaced part is of course exactly the same as volume of immersed part of the object, and the buoyant force, the value of buoyant force is exactly the same as weight of this displaced part of the fluid. So remember, density of fluid times volume of the object, which is the same as volume of the fluid, is the same as mass of the displaced part of the fluid. Okay? Today we will be talking about conditions. I'm going to present 4 situations when you can calculate a buoyancy or a buoyant force, or you can state that object is sinking, is moving towards the surface, or is stationary underwater like a typical fish. Okay? So write point number 1. Object sinks. Okay, so let's look. When does object sink? Let's imagine again, this is our surface of, let's say, a water. Okay, let's use water as our fluid. And we have an object. Okay, object experiences 2 forces: gravitational force, which acts down, and buoyant force, which acts up. Of course, object is sinking when overall force is directed down. So when gravitational force is bigger than buoyant force. Okay, so this is condition for sinking. When gravitational force acting on the object, or basically when the weight of the object is bigger than buoyant force, which acts always oppositely to the gravitational force, then overall force is directed down and object accelerates down. If we will assume that friction resistance of the fluid is negligibly small, then object accelerates down. Is it clear? Okay, so let's evaluate this. What is a buoyant force? Buoyant force is density of liquid. I'm going to write fluid, but let's think about water, times gravitational acceleration times volume of the object. Object sinks, which means that the whole object is immersed. What is gravitational force? Gravitational force is mass of the object multiplied by gravitational acceleration. Okay, of course this is not the equal sign, sorry. yeah, gravitational force is bigger than buoyant force. So gravitational force, this is gravitational force, and this is buoyant force. Here we have a buoyant force. So when mass of the object times gravitational acceleration is bigger than density of fluid times gravitational acceleration times volume of the object. Okay? And what is a mass of the object? I hope that you remember equation linking density, mass, and volume. Formula triangle for the link is given here. So mass of the object is density of the object times volume of the object. So except mass of the object, I'm going to write density of the object times volume of the object. And this must be bigger than density of fluid times volume of the object. What does it mean? Both hands we have volume of the object which can be crossed, and we have final condition. When density of the object is bigger than density of the fluid, then gravitational force is bigger than buoyant force, and object, what? Of course, sinks. Okay? So, remember this. Heavy object or heavier object means that object has density which is bigger than density of the fluid in which it is. A block of steel which is placed in the water. Steel has bigger density than water, so steel sinks because gravitational force is bigger than buoyant force. Okay? So please copy this, and the most important is that object sinks when gravitational force acting on the object is bigger than buoyant force, so when density of the object is bigger than density of the fluid. Okay? Please stop video, copy this, and when you will be ready, turn it back. Okay, point number 2. Object moves towards the surface. Towards the surface. Okay, what does it mean? Let's imagine a situation when you have light object, like, I don't know, balloon which is placed underwater and buoyant force acting up. Okay, of course, object can move towards the surface only if buoyant force is bigger than gravitational force. Okay, when buoyant force is bigger than gravitational force, then object moves towards the surface. When is buoyant force bigger than gravitational force? Of course, if density of the fluid, in this case, is bigger than density of the object. Or other words, when object is lighter than fluid. Object has less density than density of the fluid. Okay, example. Let's imagine a balloon which is placed underwater and released. Balloon is very, very light compared with water around. Balloon has much more smaller density than density of water. So buoyant force acting on the balloon will be much more bigger than gravitational force acting on the balloon, and balloon will be moving up towards the surface of the water. We are not interested now. We are not interested what happens on the surface. We are interested what happens underwater. Underwater, balloon moves towards the surface because its density is less than density of the fluid. Okay? So this is our second point and second condition. Object moves towards the surface if density of the object is less than density of the fluid, so when gravitational force is less than buoyant force. Please copy this, and you will be ready. Then point number 3. Okay. Point number 3, object stays in the fluid. Not on the surface, inside the fluid, like a small fish. Okay, this is surface, and this is our object. When does object stay? Object, again, experiences two forces, gravitational force and buoyant force. And when these two forces are equal, then object is stationary or moves with constant speed, but let's assume that today object is stationary. So when buoyant force is the same as gravitational force, then object is immersed in the fluid and doesn't accelerate up, doesn't accelerate down, like a typical fish. Okay, so fish is an example of this situation. Okay, fish in average has density the same as density of the water, because it happens, buoyant force is equal to gravitational force, it happens when density of the fluid is the same as density of the object. Okay, so when fluid has the same density as the object, or object has the same density as the fluid, then it stays in the fluid like a fish. Okay, so we have something like equal or balanced forces. Object stays inside the fluid or underwater when these two forces, buoyant force acting up, is exactly the same as gravitational force acting down. Okay, please copy this. When you will be ready, tell me. And next. Of course, you don't need to tell me, I don't hear you, haha. Okay, object on the surface. Okay, let's imagine object which was lighter when it was immersed in the fluid. Of course, this object traveled towards the surface and now is floating on the surface, partially immersed. Okay, what is the balance here? Still we have two forces, gravitational force acting down and buoyant force acting up, but remember now we cannot compare densities of the object and density of the fluid, because buoyant force acts only on the immersed part of the object. In this case, when object is floating on the surface, it's not immersed at all, it's partially immersed. And buoyant force, to calculate buoyant force, we have to find part of the object which is immersed. In this case, we have the same balance. Buoyant force is the same as gravitational force, but remember that buoyant force acts only on the part which is underwater. So to calculate buoyant force, you have to use equation density of the fluid times gravitational acceleration times volume which is under water. Volume of this which lies below the level of water. Okay, so example, a typical ship. Okay, ship is not immersed at all, it's partially immersed. Okay, when ship is partially immersed, then gravitational force which acts on the whole ship is balanced by gravitational force which acts only on this immersed part, only on the part which is below the surface of the water. Okay, copy this and let's do a conclusion. Okay, so what is conclusion? We have four situations. First situation, when overall force is directed up. Okay? Overall force is directed up means object travels towards the surface because buoyant force is bigger than gravitational force. So when density of the object is bigger than density of the density not of the object, density of the fluid is bigger than density of the object. Okay, I've presented this as the second, so I'm going to move it down. It will be our second, yes? Okay, first was object sinks. This is the surface, this is object, and overall force which is directed down. Of course, in this case, object is heavier, so gravitational force is bigger than buoyant force, or buoyant force is less than gravitational force. So in this case, we have density of the fluid, which is less than density of the object, or density of the object is bigger than density of the fluid. Okay, third situation, object stays in the fluid when buoyant force is the same as gravitational force, so when densities are the same, density of the fluid is exactly the same as density of the object. And last situation, object floats on the surface and then object is partially immersed, and again buoyant force is the same as gravitational force, but in this case you must know that buoyant force acts only on the part of the object which is underwater. Ta-da! Okay, so I hope you understand this. Please copy this conclusion also. When you will be ready, turn video again. I'm going to give you a correct answers of your test you wrote last time. Okay? So exercise number 1 was about second Newton's law of motion. Of course, and 4 points. Of course, to get 4 points, you have to write second Newton's law of motion. So when object experiences unbalanced force or resultant force, or if resultant force acting on the object is not equal to 0, resultant force, then object accelerates. Of course, you must write equation linking resultant force with acceleration. This is necessary. And it's written in the text, and give me 2 examples. So example with acceleration, I don't know, kicking the ball. Okay, and you must write here that the ball accelerates. It was stationary, now it moves. So force during kicking acts on the ball, and the ball accelerates. Okay. Second, a starting car. Okay. Again, you must refer to unbalanced forces. When a thrust force is bigger than a resistance force or resistive forces, then car changes speed, it accelerates. Okay. Exercise number 2 was about first Newton's law of motion. You can score 3 points. Okay, first Newton's law of motion plus 1 example. First Newton's law of motion is opposite to the second. So when object doesn't experience a resultant force, or when a resultant force is equal to 0, it's the same. When the resultant force acting on the object is 0, then object doesn't accelerate. Doesn't accelerate means doesn't change velocity. Not speed, velocity. Velocity is important word here. Doesn't accelerate or doesn't change velocity. Okay, and example. Very, very good example is stationary object like book, which is resting on the desk. Book is attracted by gravity, but it also experiences a force from the desk. In this case, let's name it a reaction force. So these 2 forces are equal. So overall force which acts on the book is equal to 0, which means that book doesn't accelerate. In this case, it doesn't move, which means that it doesn't accelerate. Of course, you can write here an example with parachuter or something like that, but you must refer to the balanced forces. Okay. Exercise number 3. Draw all forces acting on the car moving with constant speed. Keep scale. Okay, constant speed. So first Newton's law of motion. You have a car which travels a horizontal surface with constant speed. Okay, v which is constant. Car experiences 4 forces. Okay, force of gravity, which is balanced by force from the surface or reaction force from the surface, or I'm going to name it surface, which is the same in length. It's very, very important because car doesn't accelerate up or down. And force from the engine, thrust force, which is balanced by resistive forces like air resistance or friction. I'm going to use resistive. And again, the length of arrow representing resistive force must be the same as length of arrow representing force from the engine. Because these forces are balanced, car doesn't accelerate. It moves with constant velocity. So here, 4 forces and arrows in a horizontal direction of equal length and vertical direction of equal length. Exercise number 4. A parachuter of mass 80 kilograms falls with constant speed equals 5 meters per second. This constant is very important here. Find total force, draw picture, explain your reasoning. So let's look. If you have a parachuter which falls with constant speed, Okay, it means that all forces must be balanced. Gravitational force, which acts on the parachuter, is balanced by resistive force acting on the canopy, which means that overall force is equal to 0. When overall force is equal to 0, then this is the answer. V is constant, forces are balanced, so overall force is equal to 0. So correct answer for exercise number 4 is 0. Okay? And exercise number 5. And it was my mistake here in the text, because except force from engine, I wrote total force. Okay, I wrote something like this. Total force acting on the object of mass 20 kilograms is 40 newtons, and object accelerates with acceleration of 10 meters per second squared. Of course, it was my mistake. Except total force, I have to write force from the engine, but I didn't write this, and few people didn't do this exercise, so I've decided to remove this exercise, because when you've used my text, the exercise is nonsense. Okay, so your answers are wrong, so I decided to remove this exercise from the test, so I didn't check. I've crossed this exercise and subtracted 4 points from the total number of points you can get. So finally, I didn't check this exercise. This exercise didn't exist. Okay? And the last exercise, exercise number 6, find tension of the string connecting two masses, show working. A nice exercise, we did very, very similar. During our lesson, we have two masses, first 2 kilograms, connected by the string with second mass, which is 4 kilograms. Okay, we have to find tension, Ft, and extra mass was and force, total force was given here 20 newtons. Okay, so nice exercise. As I said, first of all, you have to find total mass as a sum of two masses, 2 plus 4, which is 6 kilograms. Okay, if you have force, you can calculate acceleration. Acceleration is total force divided by total mass. Total force is 20, total mass is 6, and how much is it? I don't need to use calculator, but during checking your test, I've used calculator to confirm this. This is 3 and 1 over 3 of meters per second squared. Okay, I don't know why most of you wrote 3 and 2 over 3. Okay, not 3.33, but 2, 3.66. 20 divided by 6 is 3, and 1 over 3 meters per second squared. Okay, and now you can calculate tension, because tension is mass 1 times this acceleration. So you have to multiply 2 times 3 and 1 over 3, which is equal to 6 and 2 over 3 of newtons. Most of you wrote 7 and 1 over 3, because most of you used 3 and 2 over 3. I don't know why. So full marks only when you have answer 6 and 2 over 3. When you've used 7 and 1 over 3, you have -1. Okay, so this is your test. Now you can check your answers and your scores compare with this. If you have any suggestions, questions, write in the form of post below this movie in Google Classroom. Thank you for watching. Learn physics, stay at home, and next lesson, calculations of buoyancy, calculations of buoyant force, so we'll be calculating. Okay, see you next lesson, bye.